So vector is said to be solenoidal if the divergence is 0, while an irrotational vector is a vector whose curl is 0. So to show that the vector given is solenoidal, we have to confirm that the divergence is 0. And for us to show that it's rotational, then we have to show that the vector has curl of 0. So let's see how we do that. So we start by saying, let the given vector be given by f. So which is given by y squared minus z squared plus 3yz minus 2x. And then you multiply by I plus 3xz plus 2xy multiplied by j plus 3xy minus 2xz plus 2zk. So let's give this vector the name f. Now, f is solenoidal if and only if the divergence of f is 0. So let's define the divergence of this vector. Divergence of the vector f will be given by I partial x plus j partial y plus k partial z. Then f vector is given by y squared minus z squared plus 3yz minus 2xi, and then plus 3xz plus 2xz j plus this 2xy then plus 3xy minus 2xz plus 2z multiplied by k. So this by definition. So this will be given by partial x of the vector or the component of I vector y squared minus z squared plus 3yz minus 2x plus partial y 3xz plus 2xy, and then plus partial z of 3xy minus 2xz plus 2z. So that gives us divergence of the f vector. So this with respect to x, we'll get -2. Here with respect to y, we get plus 2x. This is respect to z. This will give us minus 2x. And then this will give us plus 2. And clearly, the sum of these terms is 0. So this is 0. So hence, f is solenoidal. Hence, the vector given is solenoidal. So that's the first part. And then the second part, to show that the vector is irrotational, we have to confirm that the curl is 0. So the vector f is irrotational if and only if curl of f is a 0 vector. So let's define the curl of the vector f. So curl of f is simply the determinant then j partial y and then k partial z of three xy minus 2xz xz and then plus 2z. So expanding along the first row, so this one has plus sign, negative, this one has plus. So we'll have I vector into partial y of this vector, will get 3x, and then minus partial z of this vector, I'll have minus 3x minus j. Now, deleting this column, this row for j, I'll have partial x of this 3xy minus 2xz plus 2z. I'll get 3y minus 2z, and then partial z of this vector here I'll get, so minus, so this will give me minus 2z, and then plus 3y, and then plus k vector, and then delete the row for k and column for k, so I'll have partial x of this vector, the 3z plus 2y minus partial y of y squared minus z squared plus 3yz minus 2x is 2y, and then plus 3z. Now, clearly 3x minus 3x is 0. So we'll have 0, I minus j into 3y minus 2z, minus is plus 2z, then minus 3y plus, so for k, I'll have k vector multiplied by 3z plus 2y minus 2y minus 3z. It can be seen clearly that this and this cancels out, this and this cancels out. So this will be 0. This and this cancels out, this and this cancels out, this will be 0. So i.e. curl of f is is 0i plus 0j plus 0k, which is simply the 0 vector. So this means that F is irrotational. Now, because we have shown that F is solenoidal and we have also shown that F is rotational, then we say, hence, this vector F in the problem is both solenoidal and irrotational. So that's how we're supposed to solve that problem. Thank you.